All right, when we left off, we were talking about periodic functions and how often these functions repeat. If you remember what we said about the tan function, it repeats every pi, not 2 pi like the other one. So really what this is saying is if I rotate 5 pi fourths and take a tan value, should be exactly the same as if I back up pi, because that's how often it's going to repeat. So in other words, I can take this 5 pi fourths and I can subtract pi from it, and I should get the very same pi value. Well, this doesn't work out nicely. I need my denominators to be the same. So if this is going to be a 4, this needs to be 4 pi fourths. So then if I subtract these, I'm going to get tan 5 fourths minus 4 fourths is 1 fourth, so tan of pi over 4. Well, if I go on my unit circle, pi fourths looks like it's going to be 45 degrees. And when I look on this right here, 45 degrees is going to be y divided by x. It's the same number, so I get 1. All right, similarly for sine function, we know that the period of this is going to be 2 pi. So I can, if I'm going 17 pi fourths, that's around the circle a couple of times, I think. What I can do is I can back up 2 pi, and I should get the very same solution. Well, if I'm backing up 2 pi, I need a common denominator once again. So times 4, I'll make that 2 into an 8, like that. So I could call it 9. Subtracting these makes 9 pi fourths. Or if I want to subtract another 8 pi fourths, to go just subtract another 2 pi, I could subtract another 8 pi fourths and get pi fourths, and get sine minus that would be pi over 4. Once again, pi over 4, we know, is a 45-degree angle. If I look at that, the sine of a 45 is going to be square root 2 over 2. All right, similarly, cosine 27 pi, we can use just some logic for this one right here. We know that once around a circle is 2 pi, so I can just keep backing off 2 pi, so 25 pi, 23 pi, 21 pi. Well, hopefully you can see that this just means go around the circle 13 times, plus half a circle would be another pi. So this should be the same as the cosine of pi. And if I go over there, that should be -1 for an answer. All right. The next thing, or last thing we'll talk about is whether these functions are even or odd. If you remember what these mean, even functions mean this. Well, let's think about the most famous even function would just be the parabola, x squared. And we said, what happens if you pick an x value like 2? Well, when you plug in 2, you get 4. And then we said, what will happen if you change that value to negative? Well, if you plug in -2, you still get 4. So we said the definition of an even function is that if f of x will be equal to f of -x. Or in other words, if you plug in the positive and if you plug in the negative, you should get the very same answer. Now for odd, the most famous odd function was the cube graph that looks like this. And we said look at a number like 2, we'll plug it in into x cubed. So we'll have 2, comma, 8. But now look what happens when you take this number and make it negative. -2 should be -8. So basically what happens, this is if you take f of -x, what will happen is it will turn the whole thing into a negative number. So really that's what it means to be even and odd. Here, if we take the positive number and switch it to negative, we should get the very same thing. Here, if we take the positive and switch it to negative, it should change the whole thing into a negative number. Well, let's check this out. Let's think about sine for a second and figure out if sine is going to be even or odd. Let's think about a positive angle like this, like 45 degrees. If I take that 45 and switch it to -45, instead of going up, we're going to go down, what happens to the sine value? Well, the sine value went from positive square root 2 over 2. It turned into negative square root 2 over 2. So if I take the input, which was 45, and switch it from positive to negative, the y value also changes. So this is going to be negative sine theta, or this is going to be an odd function. Okay, well, we know cosecant follows the sine wherever it goes, so this one will be negative cosecant theta as well, and this one will be odd. Well, let's talk about cosine. Let's use that very same example. Let's talk about a 45-degree angle. Well, if I switch from 45 to negative 45, my cosine actually stays exactly the same. Here, the cosine of a 45 is square root 2 over 2. Here, the cosine of a negative 45 is square root 2 over 2. So switching the input from positive to negative did nothing. So that makes it an even function. So cosine theta. Here we get secant. We should know that the secant follows the cosine around wherever it wants to go. So these are the same. These are both even functions. Okay, last one let's think about is the tan. Well, if I take the tan, let's try that again. We'll just use a 45. Well, we know that this is going to be y divided by x, which is going to be positive. And hopefully we can see that if we take this and we slide it down here to negative, this is going to be negative divided by positive. So it'll switch from positive to negative like so. So switching tan will also make negative tan theta. This is an odd function. And then the other one, similarly, cotangent will do the same. Negative cotangent theta. This one is also odd.